Hey folks, Mr. Dell here. We are looking at multiplying fractions and decimals and kind of going through that process. So we have a problem that I'm pulling from, this is from CPM's course 3, and this is section 7.1.3. Directions say to simplify each expression. So it's doing this without a calculator is what I'm hoping we can do. Multiplying, in this case, a fraction times a decimal, fraction times a fraction. We have a normal fraction times a mixed number. So all of those little nuances here of multiplying rational numbers. So we're going to start with A, and it wants 2/3 times 0.8. So I've got an option. I can try to put the 2/3 into a decimal and then just multiply them together, or I can turn that decimal into fraction, right? So you gotta do one or the other. When you're multiplying a fraction and a decimal, you want them to be the same, either both in decimal form or both in fraction form. So I'm gonna convert this into a fraction, because when I look at that, if I read this decimal, it's 8/10, right? 8/10. That's it as a fraction. When you turn a decimal into a fraction, read the decimal. That's in the tenths place, 8/10. So I have 2/3 times 8/10. When I multiply fractions, you have a few things you can do. One, the quickest thing is just multiply straight across. When you multiply fractions, no need for common denominator, just multiply straight across. 2 times 8 is 16, 3 times 10 is 30. Then the last thing we want to do is make sure we simplify our fractions. So in this case, I can simplify by dividing top and bottom by 2. So my answer is going to be 8/15. And that's as far as I can go with simplifying. So that's A. B, this one here, once again, we've got fractions already, but I want to point something out. When you multiply fractions, remember the multiplication just happens straight across, right? So if I write this process, I'm saying 4 times 3 and 3 times 7, right? 4 times 3 on top, 3 times 7 on the bottom. And what do you notice you have? You have this factor of 3 top and bottom, right? So these threes can actually cancel out. They actually can simplify out before I multiply. Because if you have a factor of 3 and a factor of 3, they can simplify out. So now we just end up with 4/7. So you have a simplified version before you actually, so you don't have to reduce it or simplify it after you multiply. This one. So once again, if I look at this, I'm looking at negative 5/6 times 4/7. So if I'm multiplying, the one thing here to remember, you have a negative times a positive, so you know your answer is going to be negative. Okay, and then a couple things we can simplify first, or just multiply straight across and then simplify. So whatever works for you. So I'm going to go 5 times 4 is 20, 6 times 7 is 42. And what do I notice? I notice that the top and bottom of this can be both simplified by 2. They're both even numbers. And I having to simplify this here in this step, so I get negative 10 21sts. Or if you notice, I want to show you, I could have simplified in this step. I could have seen that, oh, that is divisible by 2 and that's divisible by 2. So I could have actually divided by top and bottom by 2 before I even multiplied across. So you can simplify ahead of time or multiply then simplify, either way. So there's my answer, negative 10 21st. Last one here. On D, this one, we have a negative 4/5, and I'm going to multiply that times, well, it's negative 1 1/3, but I want to have it, I can't multiply it in that form. I've got to put it as a single fraction. So remember, to put in a single fraction, it's the denominator times the whole plus the numerator. 3 times 1 plus 1 is 4, so this is actually 4/3. Negative 1 1/3 is 4/3. Okay? Now I can multiply, and it's negative. I forgot about that. Don't forget there's a negative there. So negative times a negative makes that a positive. So all of that becomes positive, and then I can just multiply straight across. 4 times 4 is 16. 5 times 3 is 15. So 16/15 is my answer. Or if you wanted to put it back as a mixed number, it'd be 1 and 1/15. Either answer would be fine. All right, there we go.